Hi everyone, in this video we're going to look at 3 ways to generate probabilities. So 3 ways to generate probabilities. So the first way to compute or generate probabilities is called relative frequency approximation. So relative, it's a really fancy name. It's actually really easy. So relative frequency approximation. And basically this means that you use the data that you have that's given in the problem. So you're approximating the probability using the data, hence the word approximation. So there's a formula for the probability of an event A. So A here could be anything. So it's an event. Could be anything we want it to be. It could be eat a taco, go to school, go to work, win the lottery, etc. So it's a fraction. And in the numerator, it's the number of times that A occurred. Okay, that A occurred. So how many times did it actually happen? Do we actually know that it happened? And on the bottom, it's the total number of outcomes. Total number of outcomes. So we're using information that's already occurred. Right? Remember, a probability is a number that describes the future. So here we're using past information to help us predict the future in a sense. Here's an example. Let's say that there was a survey of 30 kids. And we know that 10 of these kids believe in the tooth fairy. So we have a survey of 30 kids and 10 kids believe in the tooth fairy. So using this information, we want to find the probability that some random kid selected from the world believes in the tooth fairy. So believes in the tea fairy. Let's call her the tea fairy. So it's a fraction, right? In the numerator, it's number of times A occurred. So A here is believing in the tooth fairy. So there's 10 kids, so 10 people believe in the tooth fairy. On the bottom, it's the total number of outcomes. Well, you have 30 kids, so there's 30 outcomes. And then you could simplify it if you wanted to. It would be 1 over 3. And that's it. So it's pretty easy. You just divide. So relative frequency approximation, very, very simple to use. 2. This is the most important way to generate probability. It's called classical probability. So classical probability. So classical probability is based on the assumption of what's called equally likely outcomes. And you have to be careful. What we mean by this is if you roll a 6-sided die, you kind of have to accept that each dot is equally likely. Or if you flip a coin, you have to assume that heads and tails are equally likely. So if you accept that, then everything that follows works. So it's a formula and it's very similar. So it's the number of ways for A to occur. So how many ways can A happen? So A hasn't happened yet, right? So probabilities are numbers that describe things that have yet to occur. So this is a more natural way. So it's how many ways can A occur? And on the bottom, it's the total number of possible outcomes, So it's a little bit different from the previous definition, and it's kind of cool that we have them both here on the screen so that we can compare. Up here it says number of times A occurred, so it's already happened. Here it's number of ways for A to occur, so it's yet to occur, so a little more realistic. Up here it says total number of outcomes. Down here it says total number of possible outcomes. So again, A hasn't occurred yet, so this is a better model to predict the future. Let's do a really simple example, just really, really simple. So let's say Jono is going to flip a coin. Going to flip a coin. Normally I would be lazy and say Jono flips a coin. So if I ever do that, just know that I'm being lazy. I really should be writing Jono is going to flip a coin, right? Because probabilities describe the future. If I say Jono flips a coin, there's no probability, right? It's already happened. So Jono has a coin in his hand. He's going to flip it. He's getting ready. It's a moment in his life. We want the probability that he gets heads. So what is the chance that Jono gets heads? So most people would look at this and say, oh yeah, 50-50 chance, 0.5, 1/2. Let's overcomplicate it. So the probability of getting heads, it's the number of ways for A to occur. So A is heads. Well, if you flip a coin, there's only one way you can get heads, right? How does that happen? Well, you get heads. The coin lands on heads. So there's one way for the coin to land on heads. And as far as the total number of possible outcomes, well, there's two ways for the coin to land, right? It can land on heads or it can land on tails. So it's 2. So it's the number of ways for the coin to land on heads. So it's one way for it to land on heads. And there's 2 ways for the coin to land. So it's 1/2. So it's a simplified example, but that's the idea behind classical probability. And the last way to compute probabilities is kind of silly, but it's worth talking about. It's called subjective probability. So subjective probability. My handwriting's pretty bad. Subjective probability. And this is just probability that's based on intuition, an educated guess, etc. So let me just write something. So based on, let me say guesses, educated guesses, right? Intuition, etc. So let's do a simple example. Kind of silly, but let's find the probability that the sun rises tomorrow. So what is the probability that the sun will rise tomorrow morning, right? So it's probably going to rise, right? Because every day the sun rises, we're used to the sun coming up and going down, so I'm going to put 1, so it's going to happen. But you can put 1 or any number close to 1, right? Because based off our experiences, our intuition, what we see every day, we assume the sun is going to rise. We don't go around thinking, oh my God, is the sun going to rise tomorrow? No, it's probably going to rise. So subjective probability is something we use all the time, right? Every morning when you start your car, if you have a car, you don't really think about whether or not it's going to start, or hopefully you don't think that. It's just something that just happens, right? So we use this all the time. And so that's an example. Here's another example. What's the probability that, let's see, the internet is working tomorrow? The internet is working, like at your house, right? If you have internet at home, what's the probability it's working tomorrow? Let's just say 0.98, right? Because it usually works, right? Internet usually works. It does go out sometimes, but most of the time things work. So, or any number close to 1. So it's totally subjective. So that's it. That's 3 ways to generate probabilities. I hope that made sense.